Hi everyone, let's continue from where we left off last time and dive deeper into the decision tree model. Among the weather conditions that affect whether we can play tennis, sunny, overcast, and rain play crucial roles. Look at this chart, which illustrates whether tennis is played under sunny, overcast, and rain weather conditions. When it's sunny, temperature and wind can uniquely determine if tennis can be played. However, humidity only can make that decision. Specifically, high humidity means no tennis, while normal humidity allows for tennis. Based on our understanding and observation, we can prove the decision tree. Pruning, in simple terms, means removing features that don't decisively impact the outcomes. This way, we can get our final decision tree. Also, we can map off the scenarios for the playing tennis and the overcast weather using the three features: temperature, humidity, and wind. An interesting observation from the chart is that regardless of the feature or its values, the result is always play tennis. After pruning, we can get this tree. Now, let's look at rainy weather. After the corresponding operations, we get the pruned tree on the right. Finally, we arrive at our final decision tree diagram. Now, let's summarize the basic idea of using the decision tree algorithm. First, we need the feature selection. This involves deciding which feature will be the root of node and which will be the no-left nodes, also known as the branch nodes. Next, we generate a decision tree. Typically, we branch off based on the feature values and move down recursively until we reach our left nodes. Finally, we prune the generated decision tree. Pruning involving removing the subtrees of the left nodes to simplify the classification tree model. I've already learned about the key nearest neighborhood algorithm and the decision tree algorithm, both of which address classification problems. Next, let's look at algorithm for the regression problem, linear regression. Look at this chart with 100 blue discrete data points. Using the linear regression algorithm, we've built a regression model based on this data. The model is y equals 45.7 times x plus 148. This model uses a linear function to modeling, and its visualization is this red one. Let's look at its definition. It found the nearest neighbors. Specifically, for new input data, the nearest neighbors to that data in the training dataset are the key neighbors. Whichever class the majority of this key data belongs to, that new input data is added that class. Now, let's think about this. Both the classification and the regression problem we've discussed so far fall under supervised learning. The provided data includes features, feature values, and labels, means each question had an answer to help AI to learn. But what if we can provide accurate answers? That's when we use the unsupervised learning to generate learning models. For example, when recommending new products based on the customer's purchase history, we can't manually create answers. In such cases, we use unsupervised learning to generate models. Unsupervised learning involves no data labels, and it's much more challenging than supervised learning. However, It helps us overcome the difficulty of obtaining the label data in many practical applications. Now we know that compared to the unsupervised learning, supervised learning can easily generate models with the help of labels, but obtaining labels isn't easy. So we need a method that lives between the supervised and unsupervised learning. That's where semi-supervised learning comes in. Semi-supervised learning only requires real value for a small subset of samples to generate a model. What are the benefits of semi-supervised learning? In summary, by effectively using the provided small amount of supervised information, we can often achieve better results than the unsupervised learning, while keeping the cost of supervised learning within an acceptable range. Where is supervised, unsupervised, or the semi-supervised learning? All three methods require data. As we know, whenever data is needed, there are a lot of upfront work before generating a model. However, in practical AI applications, if we want a computer to use a self-learned strategy to get model generation without training data, we call this learning method reinforcement learning. The biggest feature of the reinforcement learning is that it doesn't require data. It only uses strategy to get the model generation progress, and finally obtain the corresponding model. For instance, AlphaGo uses a reinforcement learning technology called policy grading. As AlphaGo makes each mode based on a strategy, the program gives continuous feedback based on the current situation, which can be either a reward or a penalty. AlphaGo adjusts and optimizes its strategy based on this feedback to finally achieve the optimal strategy. Alright, in this lesson, after understanding the classification learning models, we learn about the commonly used machine learning method. I hope you can further review the learning material after class. So, that's all for this lesson.